Hello method students. We start something new with chapter 14. Recently, so far, you have learned how to graph one variable. For example, you have learned how to make pie charts and bar graphs to graph categorical variables. And for quantitative variables, you have learned how we do histograms, box plots, and stem plots. Now you will learn how to make correlations between two variables, because all the graphs you have learned to do and to read so far are used to display one variable at a time. But in social science, we are very interested in the correlation between variables. So for this chapter, you will start learning how to make scatter plots and how to read them. Scatter plots exist to make a correlation between two quantitative variables. And later on, you will learn how to make a correlation between two categorical variables. But this is another story. A scatter plot looks like this. You have a nice image here. And I'm sure you have seen scatter plots before. In a scatter plot, each point represents the relationship between two quantitative variables related to the same subject. So here, each blue point represents a couple. And in this couple, there are two quantitative variables, the age of the wife and the age of the husband. In a scatter plot, the explanatory variable, what we call the independent variable as well, always goes on the x-axis, on the horizontal axis. And the dependent variable, we also call it the response variable, goes on the y-axis, the vertical axis. So remember it like this: y depends on x, or x explains y. So when you do a scatter plot, when you use a software to do a scatter plot, you always have to think in your relationship between two variables, which one is the explanatory and which one is the response variable. For example, if I want to find the relationship between age and incidence of heart attack, here age is my explanatory variable, so it will go on the horizontal axis. If I want to find the relationship between the hours spent studying by a student and his grade at a final exam, the grade at the final exam depends on the hours spent studying. So hours spent studying is the explanatory variable going on the x-axis. Sometimes might be a strong relationship between two quantitative variables, but none of them is clearly the explanatory or the response variable. For example, here, the third bullet, the length of your femur, your leg bone, and the length of your humerus, your arm bone. These two variables are clearly correlated. They depend on your general height, but there's no clear dependent and independent variable here. There's no clear response or explanatory variable. So you can put any variable on the y and the x-axis in such a case. When you read a scatter plot, you have many things to look at to be able to understand the relationship between two variables. First, you look at the form of the relationship. It can be linear or non-linear, a curve. You look at the direction, which can be positive or negative, and the strength. A relationship can be weak, moderate, or strong. You will see images to illustrate that in the next slides. Also, outliers are important to look at because they will influence the strength of the relationship between two variables. First, the form of the distribution in a scatter plot. On the left picture, you see a clear linear form, a linear relationship. On the right, this is a non-linear relationship. You see a curve. Then the correlation between two variables can be positive or negative. A relationship is positive when the two The correlation between two quantitative variables can be positive or negative. It's positive when the two quantitative variables go up at the same time together. For example, here in this scatter plot, you see the correlation between the weight gained, which depends on the calories consumed. When someone consumes more calories, the weight gains goes up. So both quantitative variables go up together. The correlation is positive. When one quantitative variable goes down as the other one goes up, they're both going in opposite directions. We say that the correlation is negative. You see here on this image that the slope goes down, it goes in the other way. This is a negative correlation between two quantitative variables. The image shows the quantities sold of a product, of a given product versus the price. So here you can see that as the price goes up, the quantity sold goes down. The two variables go at the same time in two opposite directions. The correlation is negative. When all data points are close together in a line or in a curve, we see that there is a very strong correlation between two quantitative variables. Here, for example, this image shows the correlation for crabs between the carapace length and the width. So when the length goes up, the width goes up as well in a straight line with a very strong correlation. You see that all the data points are clearly grouped together. Sometimes the correlation between two quantitative variables is very weak, as you see here in this image. We barely see a correlation here. So it looks like a cloud. This is a weak correlation between two variables, between two quantitative variables. The image shows the correlation between the household income, so each point represents a household, and the well-being of in this household. So there is a trend to a positive correlation. It goes up, but the correlation seems very, very weak because the data points are not all grouped together along the line. When you read scatterplots, you also have to look at outliers. But be careful, not all data points that are outside the bulk of the distribution are necessarily outliers. For example, here, you can see a scatterplot showing the correlation in the United States for each of the states, the correlation between how many percent of voters voted for George Bush and the fertility rate in these same states. So you can see a positive, clear positive correlation, pretty strong here. The more babies women have in a family, the more chances they have to vote Republican. But there is one data point on the upper left that is totally a part of the group of points. This is probably Washington, D.C., where there is a very low fertility rate and people tend to vote Democrat a lot. You see this point is apart, but it follows the trend. It follows the line. We call it a regression line. We'll learn that later. It's not outside of the trend. So this point here is not an outlier. This scatter plot clearly shows an outlier, the one at the center up. This data point is clearly outside of the trend represented by the other data points. So this is an outlier. It's totally outside of the distribution. The correlation coefficient is a number. that we represent with letter R. It describes the direction and the strength of a straight line correlation. R can be anywhere between -1 and +1. It can never be higher than 1, and it can never be lower than -1. R can be 0 or close to 0. It means that the correlation between two quantitative variables is null or very, very, very weak. When R is 1, it means that there is a perfect positive correlation. If R is -1, it means that there is a perfect negative correlation between two quantitative variables. So when R is anywhere between 0 and 1, it's positive. It means that there is a positive correlation between two variables. When R is anywhere between 0 and -1, it can be, for example, -0.4, it indicates that there is a negative correlation. The closest R is to 1 or -1, the strongest is the positive or negative correlation. For example, here in this image, in the upper left, you can see a distribution of data points that is like a cloud. There's no trend here. The correlation is very, very weak. We can say it's very, very close to 0. On the upper right, you can see a medium correlation. There is a trend. You see it's positive, but it's not very strong. So in such a scatter plot, we could say that the correlation is, let's say, 0.5. In the right, but down, you can see a very strong correlation. It is negative. The slope is going down. And it's very strong. There's a trend in the data points. They're grouped together. So we can see here that the correlation coefficient must be very close to -1. The coefficient correlation R is not affected by the slope. We will learn in the next chapter to read the slope in the scatter plot, but the slope does not influence if R is close to 0, 1, or -1. It is the strength of the correlation that will say if R is close to 0, 1, or -1. And also R has no unit. It's not expressed in kilograms or dollars or points. It's R. It stands by itself.